Welcome to our neural networks video. In this video, we will talk about the training neural networks, exploring various techniques and strategies to enhance their efficiency and effectiveness. We will accompany each concept with detailed code examples using Python and TensorFlow. Training a neural network involves adjusting its weights and biases to minimize the difference between predicted outputs and actual targets. This process, known as optimization, typically involves the following steps. Forward propagation. During forward propagation, inputs are passed through the network and predictions are generated. Loss calculation. The difference between predicted outputs and actual target is calculated using a loss function. Backpropagation. Backpropagation involves calculating gradients of the loss function with respect to each parameter in the network, allowing us to update the parameters in the direction that minimizes the loss. And parameter updates using optimization algorithms such as stochastic gradient descent, SGD, or its variants. The parameters of the network are updated to minimize the loss. Optimizing the performance of neural networks involves improving various aspects such as convergence speed, generalization ability, and computational efficiency. Let's explore some techniques to achieve these objectives. Learning rate scheduling. Adjusting the learning rate during training can improve convergence and prevent oscillations. Common strategies include exponential decay, step decay, and adaptive methods like ADAM optimizer. Batch normalization. Batch normalization normalizes the activations of each layer, making training more stable and accelerating convergence. Regularization techniques. Techniques like L1, L2 regularization and dropout can prevent overfitting and improve generalization. And early stopping. Monitoring validation loss and stopping training when it starts to increase can prevent overfitting and improve generalization. Training neural networks and optimizing their performance are essential skills for anyone working in the field of artificial intelligence and machine learning. By understanding the principles behind training and optimization techniques and implementing them effectively, you can build powerful models that achieve superior performance on a wide range of tasks. Experiment with different techniques, monitor performance metrics, and refine your models iteratively to unlock the full potential of neural networks in your projects. Happy coding, and may your neural networks thrive in the world of AI. Bye bye.